Cool. Welcome, everybody. This is the first meetup we've had for a while. It's also the celebratory Decade of Go edition of the Auckland Go meetup. Please do take photos and tweet with hashtag GoTurns10, and we'll get started. So today we're just going to have hang on. Just the usual, I don't know how to work a computer. Cool, so I think this schedule is slightly the wrong way around. We're gonna have a bit of an extended intro and announcement section today, and then we're gonna switch around. Rob, as according to the meetup description, Rob will go next. Then we'll have pizza at about 7, and depending on timing, Rustam might be before it, but I think probably Rustam will be after that, talking about database testing. So GoTurns10 is a global event where meetups around the world during the month of November are celebrating 10 years of Go, and yeah, there's a couple of other things which we'll bring up during this announcement section that we're going to do. The Pass the Go for video is something that we'll try and get everyone in the background. We'll just do it and you'll see the results. And then there's a special treat organized by Vend. So thanks very much, Vend, for the cupcakes, also for organizing and providing the venue and drinks and food. So I'm just going to quickly do a few slides about 10 years of Go, just a whistle stop, because this is just a few minutes before the real talks begin. So these slides are stolen from Carmen Ando of Google's talk from GopherCon AU a few weeks ago. And so she had a long 45-minute talk about 10 years of Go. There's a lot of detail on here, so I'm just going to pick out some things. So when Go began in 2009, can you believe GitHub was either only just created, but probably very few of us would have heard of it, and then loads of real household name technologies were beginning at that time. So along the left, we've got ecosystem, language and tooling, and cloud. So part of the message that Carmen was trying to communicate was that Go really has been closely aligned with the development of cloud computing, and technologies built on top of Go have appeared throughout these 10 years. So particularly that whale over there, Docker, it seems strange that it was only 2013 that Docker appeared, but also YouTube, lots of things there. And shout out to Go Auckland, our first meetup there. I looked up, that was in we had a Google group started by someone called Tilts in Wellington. And then I came on in March of 2013 and said, hey, does anyone want to meet up? Is Evan here? Oh, he had to go home. Evan said almost immediately, yep, let's do that. It took a few months, and we had one, and then the second one, Piotr came to and said, hey, how about Vend takes on the meetup and pays a subscription, and that was all the way back then. So 10 to the 5 users worldwide, someone can do the math there. And yeah, Go 1. Does anyone here have experience of Go pre-Go 1? So Evan, I was hoping to say with him here to embarrass him, he used it and contributed a package to the original Go 1.0. So next few years, lots of really important events happened. Kubernetes appears 2014, that's quite a big one. First GopherCon in Denver, 2014. So you can see this Go conferences starting to ramp up soon after that. And the second GopherCon was about the time that GoBridge was announced. and Women Who Go were announced. So those are, and also the Code of Conduct. Those are organizations that focus on inclusion and diversity, and that's something that's been really growing as well lately. So there's some other things to do with the language and tooling context, GC improvements, and then in 2017 we've got, these are real random snippets, but there was a blog by RFC about Tools 2.0 where people started getting excited about generics and things like that. That huge picture there, I don't know if anyone's seen it before, but that's a picture of what the cloud computing ecosystem looks like in whenever that was. So you may have seen it a few years ago. And the main takeaway of Carmen was that 3/4 of those tools, including Kubernetes and Docker and all that, were all written in Go. So that's where she was going with that. Cool. So 2018, 2019, there's a couple more Auckland specific things there. We've got, in terms of the Go stuff, we've got the VGO papers, which eventually led to Go modules, which was one of the more recent big changes that's happened in Go. And then, so last year we had quite a few meetups in Auckland, about 6, and that was really good. This year there's only been 3, so that's not great. So apologies for that, but some news coming up. So one thing, a bunch of people here who went to GoForCon in Australia. Sweet, quite a few, eh? So that was an amazing event. And here we are now, Go turns 10. So last slide from me. This is the just some announcements. We have a new logo designed by a fellow called Rob Baines, Telecoder on Twitter, and he's got a website where you can buy these t-shirts and lots of other cool designs. We finally, after 6 years, got a Twitter handle since yesterday. So yeah, announcements may come through there in the future. But yeah, we're hoping to set up more frequent events in 2020. So I would like to ask Farzana if she's got any thoughts about that. Sorry, Lucille.
Okay, so I think we're all happy to be here. It's nice to have a meetup about Go. And yeah, it's nice because we have good talks with good content to help us to improve our knowledge. We have also the possibility to talk about our own projects and to do some networking. So that's really nice. But it could be difficult for people who are maybe new to Go to join us because they could feel that maybe they are interested in the language, but they are not, they don't want to get out of the comfort zone and start coming here and have like deep content very deep in Go. So, so it could be even harder if you're part of an underrepresented group and you can think, okay, maybe this is not for me. So that's why we want to change that. And we want to do something to make the Go community more open. And so we are announcing GoBridge New Zealand. So for people who don't know what GoBridge is, it's a non-profit which is handled by Google. And the goal is to empower underrepresented people in tech and to improve the diversity and inclusion in the Go community. So it's only good stuff. So for now, so it's New Zealand. So for now, we are starting this new chapter in Auckland, and we also have someone in Wellington ready to start new events. And I will let Courtney explain what we're going to do.
Yeah, so we've started looking at what we can do for GoBridge. And yeah, obviously beginner-friendly sort of things. We're looking at hosting another meetup. So obviously we'll still have this Go meetup, but a more beginner-friendly GoBridge meetup in Auckland, and we'll see about Wellington as well. Probably here too, but we'll have to confirm that also. Also things like workshops, mentoring, networking, the usual stuff. We're thinking of probably kicking it off next year, considering the timing. But if anyone is interested in speaking at something like this or helping out, mentoring, all these sorts of things, do let us know. This is the QR code for the meetup group. So yes, if you're interested, please join. Yeah, and we also have a, if you are in the Gophers Slack community, we've created a Slack channel, GoBridge-New Zealand. So there is a GoBridge one, but this is the New Zealand specifics one. There's not much in there at the moment, but feel free to get in there and chat to us. Again, Meetup QR code if you're interested. Yeah. Anything else?
So we will be looking for volunteers to help with sort of like mentoring, and we want to get more involved in having people do talks. We also want to have people do sort of more practical hands-on activities, and that can be a bit intimidating for new peeps. So we will definitely need people to volunteer and help us out with that. And also just let us know what you want to do. Like, do you want to build more? Do you want to hear more like stories? And we'll definitely try to accommodate that to suit everyone. There will be a survey in a few days. Thank you.
Thanks, everybody. So sorry, Lucille. So yeah, just one last thing I'd like to do. Where's Renan? Before we have our first speaker, which is going to be Rob, we're just going to have this very short video that we're going to film with a couple of organizers in the foreground. Piotr, I think you'd like to come up? No? Maybe Lucille? Yeah. So what we're gonna do is there's this funny, very short video that is being filmed by every meetup, and what's going to happen is we need one volunteer who's going to throw a gopher into shot. One of us is going to catch it. Everyone in the background. So Renu, if you could stand here, and we'll film with the audience in the background. Everyone's going to shout "Happy Birthday, Go!" and then we just throw it off to the other side. Does that sound good? Yeah? Cool. So, which side do we need it? Do you remember which side it is, Renan? Which side the gopher is going to come? It's going to come from that side, definitely. Yeah. And then, happy birthday, Go. Yeah, yeah. What would look best? So he needs to be out of shot. Oh, he needs to be out of shot. Yeah, so. Sorry. Okay. Yeah. So, happy birthday, Go! Yeah, one more just in case. Okay, so that means that I just get through you. Yeah, just. Oh, beautiful. Okay, you ready? Happy birthday, Go! Well, that was, thanks. Yeah, so that will get compiled into a big global video, I think. So next up, I'd like to introduce Rob, who may need a second to get his computer sorted. But Rob's going to talk about Go 3D, building a game engine using Go. Is that the title? Yeah, it's close enough. Cool.
Word. Sorry, it's refreshing. Yeah, cool. Yeah, it's pretty slow. Hello. I just got back from a bushwalk, so I'm like totally chill. So this is gonna suck. So just to set expectations really low. I'm going to talk to you a little bit about. Oh, by the way, my name's Rob. I work at Movio, which is the arch enemy of Vend. So if any of you Vend people want to come over, you're more than welcome. You took our AM, so we could take some of you. That's fine. So I'm going to talk to you a little bit about OpenGL, Golang and OpenGL. And my goal here is by the end of this, you should at least have kind of a rough idea, if you wanted to start playing around with this stuff, what you would have to get into. So it's not going to be super comprehensive. But if you do have any questions, just go for it. You don't have to ask for permission, just forgiveness. So the whole point of this was I wanted to port my JavaScript game engine, which is a whole talk into itself. So I'm going to open this up. This is probably going to be a little bit fun. So this is completely written in, well, it's in TypeScript, but JavaScript. It's written from scratch. There's no libraries involved. Here, I'm going to put this down, sorry. Depending on what the presenting, it's not so good. But it's 60 frames a second. It's got dynamic lighting. It does Rustam calling. It's got skyboxes. It's got an editor, and it's really slow because it's presenting to Google, which is really irritating me because I spent many sleepless nights making it not do that. And you can attach objects, behaviors to objects. You can do all kinds of stuff. I stopped working on this because of Google Stadia. It's me over Google. So that's that. So what I decided to do was take that and port that over to Go. The reason I wanted to do that was I wanted to do it in Wasm, or Wasm, however you say it. Because fighting with Chrome's garbage collector was incredibly difficult. I won eventually, but it was really hard, and I figured I could do it really nicely in WebAssembly because you have better control over memory management. But then Savan gave a nice talk and told me how slow it was. Somewhere back there. Oh, there you are. One of the other Go meetups, I think it was the last one. So I kind of stopped working on this as well. But the end idea of it was that, and also I wanted to run GPU jobs on low hardware, low-end hardware. So like Raspberry Pis have a little GPU in them, and if you could distribute jobs across multiple Pis, it could be interesting. We do a lot of work with vector stuff at work. And it would be really interesting to try to do something like that. And then also sign distance functions. And again, these are things that maybe you can think of to build yourself because these would be really cool. And sign distance functions are basically like that little graph over there. There's no models involved in that. It's all math based on how far away something could possibly be from something. And then you could do some really interesting stuff with visualizations. Again, we do a lot of like multi-dimensional vector stuff, and it would be really cool to be able to visualize that in interesting ways. And another one that we saw at the Golang, the GopherCon, thank you very much, was just a UI kit. Like I could go on a little bit of a rant on how the internet right now is basically a Word document with VB script in it. And that's how user interfaces are built. And it'd be really nice to have some sort of really cool application, GPU accelerated real user interface. So those are all my massive ideas that I'll never ever get to. So let's start checking this out. So to get things going off, you're going to need a couple libraries. You're going to need to use CGo. So if you use CGo, you're not using Go. I think it was Dave Cheney who said that, or maybe it was Rob Pike. CGo is not Go. But you have to use that, and there's these two libraries that are really nice. GOGL will give you the Golang bindings to OpenGL, and SDL, the Simple Media, Direct Media Layer, which is a terrible name, will give you a windowing thing. And we're going to take a quick look at just basically opening a window. So we'll start out with something very basic. So here at the beginning of this run function, you can see we just create a window, create a context, set some little variables, create a window here. You can pass in particular, like or things together, which is super old school. All the C programmers out there. But you can do different things like make the window full screen if you want. And then at the end of this, I just pass this into a game loop. And let me compile that really quick. This is actually kind of difficult with the microphone. Oh, okay. See, one thing, Movio doesn't give me fast computers, man. And there we go. Look at that. We have a window. That's great. Thank you. By the way, this code, the mesh code, is all online at GitHub, and I'll send you the link so you can play around with it. Yeah, yeah. Yeah. The SDL is basically what almost all, well, up until recently, I think almost all video games were using that to actually create the windows. Yeah. There's other ones as well. I just went with that one. I don't know why. Yeah. So how does a GPU actually work? Wow, that is a small image. So when I initially started writing the JavaScript version, I thought it was like a canvas, and you just throw an image at it, and Bob's your uncle. There you go. You got a 3D video game. But it's a lot more complicated than that. You have to create basically this memory buffer thing that the CPU. This is really badly named. Sorry, but you basically say there's going to be a communication between the GPU and the CPU, and I'm going to put all my stuff in that memory buffer, and then at a later date, you call a shader, which then operates on that memory. Then it eventually comes out with other buffers, which is generally just right to the screen. So we'll go through each one of these in parts. So also, when you talk to a shader, you basically pass in different values. So not only do you have the kind of connection buffer that you're speaking between the GPU and the CPU, you can also pass in, right before you call the shader, different things called attributes, or I'll show you some examples of code, but they're basically just static things that the shader can use to manipulate the data you're passing in. It's all very abstract, but it'll get a little clearer here in a minute. So this is setting up what's called a GL context. Let's jump over to it. And so you can see it looks for a version, the version of OpenGL. Macintoshes only support 2.1, which initially was why I started going with OpenGL as opposed to Vulkan or some of the other newer graphics libraries, especially for the Raspberry Pi I was talking about earlier. And then you also have these viewports, and kind of like SVG, you know how when you have SVG, you can make a canvas, but then you can have the SVG different size. You set up a viewport, you can set in some flags, and you can read all about these. It goes on for days, but this is just a basic a depth test and some different things. So that's just basically saying, I'm going to use this area to draw. Then you define those buffers like I was talking about. And we're going to look at what some of these look like. So when you load up a model, a 3D model, you have different points. So like you have a cube, and each one of the vertices on a cube is in this vertex buffer. And then you also have an index buffer to say, you know, if you have a box that shares two vertices, you don't have to resend all the vertices. You just send the indexes of the vertices. Let me show you what one of the vertex looks like. So this is laying out in memory what's going to be communicated between the CPU and the GPU. So you can see that we're defining the first part of this buffer to be the XYZ coordinate of one point, the color at that point. If you have texture coordinates for doing texture mapping, the normals and the tangents. If you guys know about normals, is basically just which way is out from within the vector. Is all this crazy? Oh, sorry. Yeah, what's up, Flo? Yeah. of which one's which. Yeah. Yeah, so it's basically like a layer here. So yeah, different video cards will support OpenGL, or you can have, I think they have different drivers. Yeah, yeah. So like for example, this Mac is old enough that it can't run Metal and it can't run Vulkan. It only runs OpenGL. Yeah. The version of the GPU. Yep. So that's basically like how you lay out the memory. And then when you fill the memory, here's some data as an example of the cube that we're going to draw here in a minute. How nice is that? Hard-coded values. So you can see this is the X, Y, Z coordinates. The I forgot what it was now. The normals, I think, and then that's the color. So X, Y, Z, color, normals, and tangents. Because this doesn't actually use any of that. All right. So now we can run a shader. So we've defined a memory location. We've filled it with data. Basically, that hard-coded data would come from a file. But we put that into this buffer. And then we would say, shader, please use this information and draw something. And so I'll show you a shader. This is a very simple vertex shader. So you can see here we have the attributes. And this is, again, the position, the color, the text coordinates, normal, and tangents, like we defined earlier, will be fed in here as attributes. Then you have these varying things. And varying moves from one point to the next. It'll interpolate between each one and give you a different value. That's what the varying, because it's varying. And then the uniform makes it always the same. So this little program will run whenever you want one single model and set these up. And I don't really want to talk about the model view projection stuff, but basically this is defining how the cube will look, actually. So this will run once per object. Then you have a thing called a fragment shader. And this is actually, if you do any machine learning, or if you're interested in machine learning or any of that stuff, these are where the money shot are. Because what this is run for every single pixel in a screen, or it could be just a buffer in general. So if you wanted to do something massively in parallel, you can actually fill in a fragment shader with a lot of interesting code. And we were, I don't know if I can talk about too much of the stuff that we do at work, but we were talking about doing a lot of parallel stuff. And this is actually where a lot of machine learning comes from. If you do, what are those, I can't remember the machine learning libraries at the top of my head, but which one? TensorFlow, that's a big one. What's that? MXNet? No, I'm thinking it's like CUDA, C-U-D-A, CUDA. Anyway, there's one you can run on AWS. What? Keras? I think that's one as well. You can run AWS clusters with these now. And basically, you wind up writing these fragment shaders in a different way. Sometimes you write a thing that writes these, that compiles to these. But this is something you can check out. Okay, so number 3, there's no profit. There was no profit. But let's actually render the cube. So it's at least get something for our money, eh? Look at that. 2 months of work. Yeah. No, I'm just kidding. No. All right. So that's the fun part of rendering a cube. But now if you want to move the cube, that's where things start getting very interesting. So again, with my JavaScript library, I did everything from scratch. So I had to learn linear algebra because I'm not a very well-educated person for the first 6 months of it. And that's where all this stuff comes from, matrices math and vectors and stuff. And I'm just going to show you a little bit that you can do it, and that it is built into this. I didn't start my timer. I sure hope I'm doing well. Am I? What time? How much time do I have? Anybody? All right, thank you. All right, now this should make everybody sick. All right, there we go. Whee! So this involves, oh, thank you. And it's actually quite smooth. It did take me a while to get it that way. So this is basically applying matrices to each point of the cube, and then just it's actually rotating the scene, not the cube, but you can't tell because there's nothing else there's no point to tell it apart from. But it's so here's some gotchas if you do go in to start doing this. This is how you, when you read through the OpenGL documentation, sometimes you have to pass a null pointer. And this is how you pass a null pointer. I didn't know that. Oh, by the way, I should have started this all out with I am not a Go expert, nor am I an OpenGL expert. This is all just me hacking around. But this is how you do a null pointer, which is weird. It took me forever and a few Stack Overflow fights with people telling me, why are you doing it that way? Did you guys know Go doesn't have generics? So the way that I initially wrote the JavaScript version, it's a lot easier in JavaScript, is to have these, so you have an object, and if you want to do something with it, you attach a component, a behavior to it, and then you just build up a list of those things. It's kind of like Unity, if you guys have ever done any Unity programming. But to try to figure out if an object has one of those components, you have to do something really gross like this, where you loop through and you look at the actual type. It's almost a type of reflection, and it's really bad. And it doesn't. This wouldn't really hurt in like a web app because the speed wouldn't be a problem. But when you're writing a game engine, you only have 16 milliseconds to get everything done, physics engine and everything before the next render cycle happens. So this would kill it. There's better ways to do this. One of them is called an entity component system, which is what I was going to move to. But anyway, Go doesn't have generics. So here's some of the gotchas. Macs only support OpenGL 1.2, like I said. New Macs are not going to support OpenGL at all, apparently. And Golang has some cool stuff with Vulkan. And this other one is another Vulkan library. So if you want to do something that's actually going to work in the future, you can check those out.
No, but not. You'll see. People will hear you over there, but here you will feel like it doesn't actually work. But, you know, yeah, I know. I never. I'm not a good friend.
Me?
No, mine. No, mine.
On that note, hey everybody, hello. We're going to have Rustam's talk now, so finish up and let's get cracking. Thank you, Rustam.
Hello. My name is Peter. A joke. My name is Rustam. I'm going to present the exciting stuff, the unit testing for database access functions. Like, look around you. Who do you see? You see brothers and sisters. And what unites us? No, not faith. It's the knowledge that unit tests are good for us. So that's what will be covered in this presentation. About me. So I'm a senior data engineer at Vend. It works better with these glasses. At Vend we have MySQL database, which is a backend for all the stuff. Postgres for as a data warehouse, and Amazon Redshift, which is a data warehouse. So during spare time, I do some side project in Go. And in the past, I worked a lot with Oracle. I'm Oracle certified engineer in expert in Zibel. I worked with the British American Tobacco and MTS, which is a Russian telecom company, sort of like Vodafone here. And I finished Moscow Aviation Institute. We're going to talk about writing unit tests for the test database and the mock, like mocking the test database. Mock is something that's not authentic or real, but without the intention to deceive. We're going to look at test and mock databases unit test examples and sample executions and caveats. So we'll see where things go wrong, hopefully. So the advantages of the test database is that it has the out-of-the-box syntax check. So basically all your statements are being checked by the database for you if you have them in your unit tests. It's close to production, hopefully. You don't have to define expectations because all the schema is set up for you. Hard to miss the migration for deployment because, like, if you miss it, your test won't work. The disadvantages is it's slower than MockDB because you have to connect to it, and it runs the real stuff. It's hard sometimes to maintain the schema and fixtures, so you need to make sure that the data you are testing with is precise. Yeah, you also have to figure out the provisioning, security, and access to the test database from CI. For example, if you're running in the Travis and your database is somewhere in AWS, so you have to, your platform team needs to figure this out. So yeah, another disadvantage is that you have to make sure that if you're running several instances of your unit test, they should run in separate schemas. Otherwise, like, you can influence the results of the test. The advantages, it's of the mock database, faster than real database because there's nothing, there's just memory. No need to run DDL statements to set it up because everything is defined in the expectations. Test data is injected in the code, so when you define the expectations, we'll have a look. You basically provide, you describe what you want your statement to return. And yeah, let's continue. Disadvantages. You have to write expectations. It's advantage and disadvantage at the same time because, like, sometimes it takes time to figure out the proper way to write it. SQL syntax errors are ignored, so if you have some, you can write whatever you want in your SQL statement. And with the mock database, if you don't have proper checking for your statement that you expect, you basically gored. Easy to accidentally forget to add a migration script. Everyone did it probably. Yeah, so we're going to look at the Datadog Go-AKL mock library. And with it, it's sometimes tricky. For example, if your function returns the row set, and the row set is from SQLX, it's you have to write a wrapper function that will chuck the expectations into that SQLX rowx instance. So the unit test plan for the test database: connect. Of course, you'll defer the close setup. Then you run your tests, and then you're done. So how to succeed in life with a mock database? First, you need and connect to the fake database. It returns you the database handle, the mock object, and the error, if any. Then you define your expectations. Then you run your tests against the test subject, which you have already, like, set it in the expectations. And then at the end, you check that all expectations are met. And if some expectations are not met, or there are some unexpected statements, then it will fail. Here we go. So example. In the example, it's a simple example with two submodules. There is types submodule which defines all the basic types in your program. and repository. So repository will contain the functions which write the data to the database itself. So basically, you provide your type to the repository, and it writes stuff for you. So an example data structure is type persona. We'll look at it briefly. And the persona repository is basically the repository for it. Persona is a basic structure. It has only 3 fields, which doesn't matter for this test. Someone wants to study it in detail? Continue. Because if you don't have it in the database, it will be null. If you have a null in database. So the repository will have, usually it has some functions like insert, update, delete, exists, which checks the record for existence, and get. This is the method description, generic, no generic in Go. So execr is an interface where you have, well, basically it's for if you have this on your in a method, you can have a database or a transaction passed to it, and it will work exactly the same. So here is our test method with some errors. As you can see, there is no comma between name and date of birth, which is unacceptable. Yeah, so here it is. Very simple. It should be doing simple things, but it doesn't. So yeah, it will take the statement, execute against the database, which probably passed in the context. I don't remember. Oh, anyway, let's continue. So here is the unit test example for the test database. Excuse me. We define a test persona. We create the repository. We check that insert worked because we don't care about insert. We're going to check the update. So the update is this. It should update the X-ray Bradbury to Ray Bradbury. And it will fail because there's a syntax error, and the real database will report this, as we'll see in the result. So yeah, this is like a screenshot from the execution of the real execution, and the test fails, which is expected behavior. Yeah. So this is the mock database example. We have the same test for the mock database. In the first line, you can see that we connect to the mock database, which is like initializing a mock database object. It returns the database handle, the mock, which will be stuffed with expectations and an error. Usually it doesn't return an error, but you know. We check the error because we are good. Then we define that we expect to see the update statement, which you saw, which contains an error in the original function. We define it as a regex because the mock supports the regex as much as the regex against your statement. We expect that this will return the result. We fake the returned result for our function, and it will be a result with which will have one row, and the last row ID is 1. Someone remembers the signature of this function. So we have the test persona. We create the new test persona repository. We run the update. We check for the error, but there's no error because it will not the regex will not fail. It does not check for the comma. So this is the result of the test execution. Yeah. It's okay. Test passed. So everyone happy, CI happy, we deploy to production. But there is no comma. Yeah. So what do? discipline. So when you write your test, you must be disciplined. You need to like maybe check your statements before, like on the real database, before you actually chuck them into your test. Come on. Testing in production is fine. We always do it. It's a joke. So then writing precise regex for expectations, which can be tricky or hard. Like if you have hard, complex updates, or like your SQL statements are complex. Yeah, well, this is only two things. Never make mistakes. Also, never. Or become a gardener or landscape designer. So I have a story. I had this. The person I knew, like at my first job in New Zealand, he used to come and water the plants in our office. I talked to him and said like, oh, well, how did you end up with like this? He said, oh yeah, I was coming to the office every day, and I was feeling angry. I was feeling frustrated every day. Like I was in the office, I was interacting with people. He was a instruction designer, so if you know like learning management systems, they have this instruction like courses for people. So he was designing one of those courses, and he said like one day I decided that I had enough of this, and he opened his own company. Now he does landscape designer and gardening, and yeah, he's very happy. So yeah, that's one of the parts. So yeah, the models used in these presentations are. The first one can be ignored because it's in the source code, but it's not visible in the presentation. For the mocking, I use the Datadog Go-AKL mock, which is quite good. I think it's the most mature from what's available. Yeah. Yeah, you can write it down. Sorry, no QR code. I don't know how to do it. So yeah, if you have any questions, now it is the time to ask. Thank you. Thank you. Yes? I was trying to test if update works. Sometimes. It depends if you use test database or mock database. It is a very good question. Like our production runs on Redshift, and we have a test Redshift database. There's not much. Probably, if you have like something hammering your test database, you need to account for that and create like separate testing schemas for the stuff. But like if you know that you're the only one, or you are the only one having access to it, or your CI is the only one having access to it, so you don't have to bother with this. Did I? Yeah. I feel good. Test, I write a unit test for a unit test. Yeah, Inception. Not in this company, but yeah, basically you generate, every time you want to run a test against the real database, you generate the schema name, like stuff it with objects, then run your test, then drop everything. I did it in Python, and it was like easy with the standard unit testing library where you have like setup and tear down things, and it worked. Yeah, if it works for you, I think it's fine. There's no like, I'm not convincing anyone to use the mock database tests against that. It's what works in your case. For example, you can't run Docker database with Redshift, so you have to use the real one. If you have the Postgres, you can run, of course, even in Travis, you can spin up the Postgres test instance and run your tests against it. Yeah, it's like a whole topic. It's quite a topic for a separate presentation. I used to work with Oracle, and every time I connect to Redshift, it inflicts a pain in my heart. So yes, but at least you know what to do. It's a joke. I guess we're done here.
Yeah, thanks everyone. Yeah, I think we're done. But I realized I don't know if you can cast your mind back about 45 minutes ago, but we never had a question section for Rob, and I don't know if people talk to you. Well, if anyone had any questions now, do add them. I know it was a while back, and you probably already spoke to him, but I feel bad for not putting that section in. But thanks everyone. Yeah. Give it a second. No one? Anyone? Okay, well, thanks everyone, especially the speakers and the GoBridge team and all the helpers today. It was awesome. And see you in the new year. Thanks very much. Yeah. So... Yeah.